Hello and welcome back. Today we are start building the real backend. We are going to create our FastAPI application, connect it to a SQLite database, and define our Pokemon data model. Okay, so for this we are going to create a folder, backend. In the folder backend, we need to move there. For this, we need to create a virtual environment. As you can see, we are starting from scratch. So we are going to start there. In backend folder, we are going to say python /m venv.penv. Okay, the virtual environment is complete, so we need to move and activate our virtual environment. As you can see, we are inside of virtual, and we need to install the libraries that we are going to use. For this, we are going to type pip install FastAPI, Uvicorn, and SQLAlchemy. Let me explain each one. First, FastAPI. This is our web framework. A web framework handles the hard part of building an API, receiving HTTP requests, routing them to the right function, validating the inputs, and sending back a response. FastAPI is built for modern Python. It is asynchronous by default, which means it can handle many requests at the same time without waiting. It is also one of the fastest Python web frameworks that exist. And something I really like, it generates interactive documentation automatically. We will see that at the end of this lesson. The second, Uvicorn. FastAPI is a framework, but it needs something to actually run and listen for connection on a port. That is called an ASCII server, Asynchronous Server Gateway Interface. Uvicorn is our ASCII server. Think of it like this. FastAPI is the car and it has steering wheels and all the logic. Uvicorn is the engine. It makes the car actually move. And the third one, SQLAlchemy. This is an ORM, Object Relational Mapper. Instead of writing raw SQL like, let me think, select everything from Pokemon where name Pikachu, name equal Pikachu. Okay, we're going to write Python classes, and SQLAlchemy generates the SQL for us. It's cleaner code, easier to maintain, and it protects us from SQL injections attacks by default. There are a lot about the internet. Okay, now let's gonna create our requirement file. For this, we are going to type, where are we? Here. Okay, we are in the correct place. Pip freeze requirements.txt. Cool. As you can see, I don't need this. Don't save. Bye. As you can see in the backend, we have the requirement list. This file lists all our backend dependencies. Anyone who clones the project, they are going to run pipe install the requirements and going to get the exact same environment. This is important for collaboration and deployment. Now we're going to create a new folder called apps, the ones who are going to contain everything. And we need to create or init.py. We need to create our database. We are going to start with the database first. Okay. So let's start with database.py. The file handles our connection to SQLite. Before I write it, let me explain something quickly. Unlike Postgres or MySQL, SQLite doesn't need a separate database server running. It stores everything in a single file on disk. It's perfect for a project. It's lightweight, zero configuration, and more than fast enough. Well, anyways, we're going to start typing from SQLAlchemy import create engine from SQLAlchemy dot extension dot declarative import declarative base from SQLAlchemy dot ORM import session marker. Now, those are the imports. Now we need to create SQLAlchemy SQLAlchemy those database dot URL is equal to SQLite 3 dot slash Ch.3. SQLite stores everything in a single local file. These 3 slashes means relative path from where the apps runs. We're going to create now an engine. We're going to create the engine. It's wrong. We need parentheses there. So in this part we are going to set the SQLAlchemy are going to connect to arguments that contains check same 3. It's going to be false. It's going to be false. Okay. Check same threads is false. It is required for SQL with FastAPI because FastAPI can handle requests across multiple threads simultaneously. For this, we need a local session. Session local is going to have the session maker that's going to auto commit, and it's going to be false. The auto flush. The flush, as you can see, all the information related to what we are using over there. You can read everything, so it doesn't matter. Auto flush is going to be false, and bind is going to assign to the engine. It's going to be assigned to the engine. This line is going to manage our database transactions, and the base is the parent class for all our database models. So the base is going to be a declarative base. To run this, we need to create a function. We're going to define the get the database. This dependency opens a database session for each request, and automatically it closes when the request finishes. To do that, we need to set the database is a sessions local. We're gonna try. We're gonna yield the database. Finally, database is going to close. And we have the session there. The getDB function uses Python yield keyword that makes it a generator function. FastAPI uses a pattern called dependencies injection. When an endpoint needs a database session, FastAPI calls getDB. It gives us the session to the endpoint, and then it closes automatically when the request is done, even if there is an error. Clean and safe. It's simple. So with this, our database file is almost done, almost for now. We are going to start doing the models. In file models.py. Now in models.py, this is where we define what our database table looks like. From SQLAlchemy, we are going to import the column method. We're going to import an integer because we need the integer and a string from database. We're going to import the base, the one we already create. Did I save? Yeah, I save. To start the model, we need to create a class to define everything. Class Pokemon. We're going to say that it's going to be the base. So this class represents the Pokemon table in our SQL database. SQLAlchemy creates this table automatically when the apps start. For this, we are going to say that the table name is going to be Pokemons. The ID is columns. I'm going to write everything there. So integer. See that? Yeah. The IDs are integers. There are going to be your primary key to find everything. The index of every Pokemon. True. We need the name too. Name is the column. String. Unique is true because there are only one Pokemon with a unique name except for Nidoran. It has that symbol. I don't remember for male and female. Index. I don't remember how this is called. But with the true, we are going to have the types to type 1. It's better for type 1. This is going to be a column there too. Everything is a column, so this is the most boring part. When you identify what you are going to use, you need to create all the things for everything. So now SP is a column that have an integer. Oh, I forgot. Not every Pokemon have two types, so it can be nullable. The second one, the first not. Every Pokemon has almost one type. So let's gonna add there some Pokés. Some Pokés have only one type. I'm going to save. We HP attack is attack, defense, special attack, special defense, speed. Column, integer, call. HP, attack, defense, special attack, special defense, speed, everything is integer. So we can continue with this sprite URL to get a column that is going to be on string 2 and the moves. Those columns are going to be strings. This is okay. The move is a list. So if this is going to store as a comma separate string. Okay, right. So this class maps directly to a table called Pokemon. In our SQLite file, each attribute is a column in that table. Nullable true. It means that a column can be empty, correct? Because, some Pokés has only one type. The unique true means that we cannot have two rows with the same Pokemon name. If we try to save Pikachu twice, the database rejects it. It's a good protection against duplicate. Now we need to create the schemas. schemas.py. This might look similar to models.py, but these two files have different purposes. The SQLAlchemy model in models.py talks to the database. The Pydantic schema in schemas.py talks to the API. One is for storage and the other is for input and output validation. FastAPI uses Pydantic automatically. When our API sends a response, Pydantic checks that every field has a right type. If something is wrong, FastAPI is going to return a clear error, and we don't write any validation code ourselves. From Pydantic, import base model. From typing, import optional, cancel. We're going to create our class where Pokemon is our base model. So this Pydantic schema defines the shape of data our API sends and receives. FastAPI uses this to validate response and serialize data automatically. When the ID is an integer, okay, ID, name, string, type 1, this is string 2, type 2 is option, I think this is optional, a string, and it can be none. As you can see, type 2 in schemas is the same, has the same syntax as models. It's nullable and it can be optional there. HP attack, defense, special attack, special defense, speed. We're going to say that is integer. Sprite.url is going to be string. Moves is going to be string 2. After we create our base model, we need to create our class. It's a configuration that allows conversion from SQLAlchemy to the model objects. To do that, we are going to do the class and config from attributes equal to the same true. As I said, this is going to allow the conversions. The form attribute is going to be true. It's going to tell Pydantic that it can convert a SQLAlchemy model object directly into a response. Without this, we will have to manually copy each file from the database object into a dictionary. With this, it's automatically. We already create the init.py. This file is empty. It just exists to tell Python this is the folder, it's a package, you can import from it. And that's all. Now we are going to continue with our main.py. In our main, we are going to set from FastAPI import FastAPI dependencies to depends from SQLAlchemy the ORM import session from database. We're going to import the engine that we create and get DB or class or function from import models, because we need to import the models that we create either. Okay, this is the fun part. We need to create all database table on startup. It's safe to call and safe to call every time. The models, the base, the metadata is going to create all binded to the engine. There are no provided. We're going to say that our app is a type FastAPI and have this information. The title is called Poke App API. Let's start with this for now. Comma. That description. Let's gonna say that is a cache Poke search discovery. And the version is going to be 1.0.0. Now we need to create our route. For this, we need to write add app. We are going to get. This is going to be the route. So let's gonna put help. We're going to continue the function to the route. Is going to be a help. Check. We are going to use this because we need to verify if the API is running. Okay? To verify if the API is running. For this, we are going to return. Let's gonna say status. Okay. Okay. The message. Okay, API running. Okay, this part, the line 6. This line creates our database tables when the apps start. If the tables already exist, it does nothing. It's a safe call every time. We're going to this part there now. This is our first real endpoint. The app get decorator says, when someone sends the get request to help, it's run this function and return the result. Okay, we need to run everything and check if everything is correct. For this, we are going to write Uvicorn app.main app /load. Let's gonna check if we had index. Okay, what do we have from there? It stores a comma, but where? In line 8. Models, line 8. What do I have wrong there? Oh, it said index. It's index. My bad. Cool, everything is running. It says details not found because I have nothing there. We didn't create anything in this route because we create everything in help. So we got the status, okay, and the message. That means our API route is currently running. Let me explain a bit about the Uvicorn command. This is our server. App.main means that look in the app folder and find the file main app. Find the file main.py. And the app is the FastAPI instance variable inside the file. Reload restarts the server automatically every time we save a change. It's perfect for development. Okay, We already checked that our route worked perfectly, so we are going to change to Redux. This is something that FastAPI gives us. Is automatically generates the interactive documentation. This is our health route. This is our health endpoint. As you can see, if we press execute, we're going to get the status 200. That means our server is, that means our route is working perfectly. So the status is running. Right now, the table is empty, but the structure is there. And in the next lesson, we are going to fill it. So that's all for now.